Okay, looking at your review, number 1 says sine A plus B. This is what? What is this based on? That's not my question. I didn't ask for the answer. I asked, what is this based on? Sum difference. So using the sum difference formula, you would have picked J. Okay, number 2 is cosine of A minus B. Again, sum difference. But please remember that cosine is the opposite. So I'm looking for cosine A, cosine B plus sine A, sine B. So you would go with K, letter K on your review. Okay, number 3 required some work. It is sum difference. It is the cosine of pi over 2 minus A. So that's going to be the cosine of pi over 2 times the cosine of A plus sine of pi over 2 sine A. How many degrees is pi over 2? 90 degrees. So that is this point right here. What's the ordered pair for that point? 0, 1, which means the cosine of pi over 2 is, and 0 times anything is, so this is out of here. Sine of pi over 2 is 1, and 1 times sine A is sine A, so you should have chosen B as in boy. Okay? Number 4. Cosine squared A is simply one of your basic identities. The Pythagorean, so it is 1 minus sine squared, which is choice H. Number 5, secant is a reciprocal identity. 1 over cosine, which is choice D. I'm going to pause for a moment. Okay. Number 6 is C. It's just a basic SOHCAHTOA. All right, 7 is the double identity. How does the double identity of cosine work? Cosine squared minus sine squared, which is choice A. Number 8 is a Pythagorean identity from that basic identity sheet. It is E. It is tangent squared. Good job. I am now on number 9. Number 9 says 3 tan x plus 3 equals 0. You simply treat it like a two-step equation. So like 3x plus 3, what would I do? Subtract 3 from both sides. 3 tan x equals a negative 3. Divide by 3, tan of x equals negative 1. All students take cash. Tangent negative is here and here. Because it's a 1, that means the numerator and the denominator have to be the same number. Sine and cosine have to be the same. What is the only isosceles right triangle? 45, 45, 90. Therefore, x is, we're looking at 45 degrees. Now, am I going to use 45? No, that's just my measurement. I'm going to use 45 in this neighborhood and 45 in this neighborhood. So 180 backwards 45 gives me 135 degrees. And for this neighborhood, 360 backwards 45 degrees gives me 315. You must show the angles to get full credit. Yes. How did I get 45? If my answer is 1 for tangent, remember tangent is sine over cosine. The only way to get 1 is if your numerator and denominator match. So 2 over 2, 3 over 3. Okay? So, where, if sine and cosine match, that means I have a right triangle where 2 legs are the same, making it an isosceles. What is the only isosceles right triangle? 45, 45, 90. Good? All right, we are moving on to number 10. Number 10 says 2 cosine squared x minus 1 equals 0. 2 cosine squared x equals 1. Cosine squared x equals 1/2. Cosine x equals the square root of 1 over 2, or 1 over the square root of 2. Is that acceptable? No. How do I fix it? Multiply the top and the bottom by the square root of 2, which gives me the square root of 2 over 2. Where is cosine the square root of 2 over 2? 45 degrees. Am I looking at positive or negative? Positive. All students take cash. Where is cosine positive? These two neighborhoods. So 45 and 315. Because I did 360 minus 45 because my angle is before the line. When the angle is before the line, you subtract. When it's after the line, you add. Good? All right. Number 11A is the hardest one in the whole packet. I probably won't give you one that hard on your quiz. Your unit test, sorry. Exam, quiz, test, it all means the same to me. All right. Number 11A, I'm going to go through the process that you should be doing on all these problems, what you should be thinking, okay? Do I know any formulas that use a 3? No. I know half, which we didn't explore that much. I know double, and I know plane x. I know 2x, and I know plane x, and I know squared. Okay? So, I need this to look like one of those. Either a squared or a 2x, an x. What would I do? Excellent. I'm going to do cosine of 2x plus x. I have now turned it into what type of problem? A sum difference. And the rule for cosine sum difference makes this become cosine 2x cosine x minus sine 2x sine x. Okay, do they have anything in common? No, but technically that 2 is attached to the cosine, right? So they don't have anything in common, correct? So I cannot factor at this point, okay? What can I do? I can substitute. I can substitute for the cosine 2x, and I can substitute for the sine 2x, yes? What is the formula for cosine 2x? It is cosine squared minus sine squared. Because I'm subbing, I'm going to put it in parentheses, and I'm going to bring down this cosine x. Okay? Minus, what am I going to sub sine 2x for? 2 sine x, cosine x, bring down the sine x. What comes next? Distributive property. How many pieces, how many terms is the pink? 2. So I'm going to distribute how many times? Twice. So this becomes cosine cubed minus, when they don't match, I just list them next to each other for multiplication. So is this side done? Yes. Minus, I'm going to use brackets here because this requires a little bit more work. Okay? Oh, no, it doesn't. Sorry, I was thinking of a different problem. So, how many terms are here? It is a single term. This is like saying 2xy, right? Times an x. Okay? This is one term. Terms are separated by addition or subtraction. There is no addition or subtraction. Okay? So who does this match up with? Sine. So it's going to become a 2 sine squared x cosine x. Okay? But it's a minus. So I really didn't need the brackets, but that's a good practice for later. Okay? Now what do you notice? I have two like terms, this and this. Remember that this is a 1. So negative 1 minus 2. negative 3 sine squared x cosine x, yes? Now I'm in trouble. Why am I in trouble? I have different trig. Can I rewrite this sign? Yeah, what can I replace it with? Okay, so 3 times 1 minus cosine squared, okay, times cosine x. Now this one's going to be a big one. It's going to take a little time. I am first going to distribute the 3. What do I get? 3 minus, oh, so close. 3 minus 3 cosine squared x. Now I have to distribute what? The cosine x now. Okay, I distributed the 3. Now there's also a multiply by cosine, yes? And when I distribute that, I get 3 cosine x minus 3 cosine cubed x. Now I have to distribute the negative right here, this negative, so this becomes negative and this becomes positive, and I'm going to bring this guy down. Now what do you notice? I have these match. So that gives me 4 cosine cubed x, cubed x minus 3 cosine x. Now, give me a second so this is clear. What can I do? Okay, it's not technically called divide, it's called factoring. So I'm going to factor out a cosine x, which leaves me with 4 cosine squared x minus 3. I now have how many factors? 2. That's a good thing. What do I do with my factors to solve? Set them equal to 0. So cosine x equals 0. Is there anything to do? No, I got to come back and find the angles, but there's no more work I can do, correct? Okay. Now I know there's not a lot of space. You kind of have to continue on. Okay, what would I do here? Add 3. So 4 cosine squared x equals 3. Now what do? Divide by 4. So 3 over 4. Now what do? Square root it. So it gives me the square root of 3 over 2, because the square root of 4 is 2. All right. When is cosine 0? 90. It's 0 on this line. So 90 degrees and 270 degrees. This one is done. Yes, ma'am. I converted sine to 1 minus cosine squared so that I would have all the same tricks. Okay? All right, so cosine is 3/2 where? Using the hand trick. 30 degrees. Where else? 330, because I want all students take cash. So these two neighborhoods, the 30-degree angle here is 30. Here it is 330. Okay? Problem done. I will scroll up because somebody had a question about the sign. I changed it way up here. I replaced this with the 1 minus cosine squared so that it would all be the same trig, because it makes it easier to factor. There are a couple cases where I don't do that, but it's very rare. Other questions on this problem? Again, this is much harder. We can probably do the next 3 combined in the same time it took us to do this one. Okay? Are we ready, or we need some more time? Good? All right. So the next one is simply a 2-step equation. Okay, tell me what to do. Minus, so sine x equals a negative square root of 3. Divide by 2. So I need negative. All students take cash. Where is sine negative? B and C right here. Using the hand trick, how many fingers need to be up? 3, which is how many degrees? 60 degrees. But am I going to use 60? No. I have to find the 60 in these two neighborhoods. Right here, I went past the angle. So 180 plus 60 is 240. Here it's before the angle. So 360 minus 60, which is 300 degrees. Problem done. Questions, comments, and or concerns? Okay. Next one says 2 cosine squared x plus cosine x equals 1. What should I do? I'm going to factor. So I have 2 cosine squared x plus cosine x minus 1 equals 0 because you cannot factor till it equals 0. I'm going to show you both methods because some of you are not good with factoring. So I will show you how the quadratic formula works. First, I'm going to do factoring. A times C, negative 2, and B is worth 1. What are two numbers that multiply to negative 2 and add up to 1? 2 and a negative 1. So I rewrite my problem to say 2 cosine squared x plus 2 cosine x minus cosine x minus 1. I have a group and another group. What does this group have in common? 2 and a cosine. When I pull out the 2 and the cosine, that gives me cosine x plus 1. Do these two pieces have anything in common? No. So I'm just going to pull out a negative 1, and it gives me cosine x plus 1, and I do my happy dance. Why do I do my happy dance? Parentheses, match. 2 cosine x minus 1 equals 0. Cosine x plus 1 equals 0. So cosine x equals 1/2. Cosine x equals negative 1. Okay, we're going to go ahead. When is, yes? This. In order to factor, if there's a lead coefficient, you have to write it out into 4 terms and factor by grouping. That's the easiest way. Some of you may have learned a box method or other ways, but that's what I've been going through. Oh, yep. This here, I factored. This and this both have a 2 cosine. When I divide this by 2 cosine, there's still a cosine left. When I divide here, if everything cancels, that's a 1. Division canceling is 1. Subtraction canceling 0. I'm doing division. Okay? So when is cosine 1/2? 60 degrees and all students take cash and 300 degrees. When is cosine negative 1? When is cosine negative 1? Is cosine x or y? X. So it's negative 1 at 180. Okay? That is one way to do the problem. I cannot emphasize enough, at some point, you need to either watch my videos or other videos on how to factor. That is going to be very important for calculus. Okay? I'm not going to I spent some time semester 1, I'm not going to do it again. You guys learn quadratic formula to solve. That also works. So, this is my A, my B, and my C. Quadratic formula is the opposite of B plus or minus the square root of B squared minus 4 times A times C over 2 times a. 1 squared is 1. Negative 4 times 2 is negative 8 times negative 1 is positive 8, which brings me to negative 1 plus or minus the square root of 9 over 4. What is the square root of 9? It is 3. So negative 1 plus 3 divided by 4, negative 1 minus 3 divided by 4. This answer here gives me 1/2 because it's 2 over 4, which reduces. This here is negative 4 divided by 4, which is negative 1, which is the same answers I got here. You just put cosine x equals in front of it. Okay? So if you cannot handle factoring, I know each one of you was taught to solve using the quadratic formula in Algebra 2. Use that method. But you need to know factoring for future. It's going to make life easier. Okay? Questions, comments? Okay, moving on to the last one in that section. Sine 2x minus cosine x equals 0. What can I rewrite? Sine 2x, what is it? 2 sine x cosine x minus cosine x. Now, here is a case where I'm going to go ahead and factor because I only know how to rewrite cosine squareds and sine squared. And I don't have that, do I? Do I have a GCF? What is my GCF? Cosine x, which leaves me with 2 sine x minus 1 equals 0. I have my two factors. Cosine x equals 0. 2 sine x minus 1 equals 0. Sine x equals 1/2. When is cosine 0? On the y-axis, so that's what and what? 90 and 270. Good job, guys. Okay, using the hand trick. Sine is 1/2 where? 30 degrees. Okay, so 30 works. It is also positive in this neighborhood. What's the 30 degree here? Yes, because it's before the line. So 180 minus 30 is 150 degrees. Okay, moving on to number 12. Number 12, yes? Okay. Yes. Let's go back. Why didn't I? Because it's not multiplication, it's subtraction. You only distribute multiplication. Okay, so we are on number 12. They need me to prove. Okay, so I have sine squared x cosine squared x plus cosine to the 4th x equals 0, yes? Oh, sorry, equals cosine squared x. Okay, which is the more complicated side that I can do more things with? The left-hand side. Okay. What do you notice? Yet you could rewrite sine squared x. I did it another way. Yes, you can rewrite sine squared x. Anyone else see something else? I'll show both ways. Yes. I can factor out a cosine squared. So I get cosine squared x leaves me with sine squared x plus cosine squared x. What do you know about this right here? Equals 1. So when I multiply by 1, does it matter? No, and it leaves me with cosine squared x. You could have also done exactly what I heard some people say. They subbed out sine squared x. So 1 minus sine, sorry, I messed that up. Sine squared is 1 minus cosine squared x times a cosine squared x plus cosine to the 4th x. Okay? When I distribute, I get cosine squared x minus cosine to the 4th x plus cosine to the 4x, which does what? Cancels and leaves me with cosine squared x. Again, with proofs, there are multiple ways to do it. Both ways work. Okay? Moving on to 12b. 1 minus 2 sine squared x plus sine to the fourth power x equals cosine to the fourth power x. I found it easier to rewrite the right-hand side because there was too many things to pick and choose over here to rewrite. So I chose to rewrite this side. What can I rewrite this side as? Cosine squared x, cosine squared x. Okay? What do you know about cosine squared x? It's the same as 1 minus sine squared x times 1 minus sine squared x. So I can use just double distribute or FOIL. 1 times 1 is 1 minus sine squared x minus sine squared x plus sine to the fourth power x. What can I do now? Combine like terms. 1 minus 2 sine squared x plus sine to the fourth x. Is that my goal? Yes, problem done. Good? Okay. Please note that 12c is a proof. So anyone that did cross multiply, you did the problem wrong because you can only change one side in a proof. Okay? So, which side is more complex? The left. Okay? What do you know about sine 2x? It is 2 sine x cosine x, and then 1 plus. This is where it gets tricky. There are 3 options for this one, right? If I do cosine squared x minus sine squared x, does that help me at all? Nope, because nothing cancels out. Okay? What if I try 1 minus 2 sine squared x? Because that's another option. It makes it more complex, right? Because 1 plus 1 is 2, and then minus a 2. So did it get me any closer? Nope. What is my third option? Cosine. What's the other rule? Look at your double angle rule. What's the final double angle for cosine? 2 cosine squared x minus 1, yes? Okay, what will this minus 1 do to this plus 1? Cancel it. And it leaves me with a single term, yes? So this is the winner, okay? So I now have 2 sine x cosine x. After the 1's cancel, I have 2 cosine squared x. Now talk to me about what else cancels. The 2 cancels, and this cancels that. So I'm left with a cosine x on the bottom and a sine x on the top. Was that my goal? Yep, problem done. Okay, let's see if we can get at least letter D done. Okay, letter D is cosine x plus y plus cosine x minus y. What rule applies? Some difference. So cosine x cosine y minus sine x sine y. And I'm going to combine that with cosine x cosine y plus sine x sine y. What happened? That cancels, leaving with me with how many? 2 cosine x cosine y. Was that the goal? Yep, problem done. Okay, letter E. Letter E says 4 sine x cosine x plus 2 equals plus 2. Okay, what do I know how to rewrite? This 2 sine, yeah, this here. So I can do 2 times 2 sine x cosine x plus 2. What's 2 times 2? 4. So 4 sine x cosine y, cosine x plus 2. Okay, wait a moment, please. Okay, so we are given that sine x is 5 over 12. What should I sketch on my paper? A right triangle. So 5, 12, using Pythagorean theorem, 5 squared plus 12 squared is 169. Square root is 13. 5 over 13, sorry. And then, so we would have done 13 squared minus 5 squared, which would have given us 144, which is 12, okay? All right, my labeling's correct. All right, they want cosine 2x. What is the formula for cosine 2x? Cosine squared minus sine squared. Sorry, this one they gave you this and this, sorry. So you should have done 13 squared minus 5 squared. Okay, so what is cosine worth? 5 over 13 squared minus what's sine worth? 12 over 13 squared. Is that correct? Wait. Sine, oh, you guys lied to me. It is 12 over 13 is cosine. Opposite over, adjacent over hypotenuse. And this is 5. So we get 144 over 169 minus 25 over 169, which is 119 over 169. Okay, sorry, I was trying to speed it up. In this problem, I see that I have it in radians. Radians is challenging for most of you, so you want to switch it to degrees. So pi is worth 180. So I do 5 times 180 divided by 12, which gives me 75 degrees. I need 2 angles that add up to 75. So that's going to be 30 and 45. So I need to do the sine of that. I need to do the cosine of that. Okay? And then I'm going to go back and do the tangent. I'm going to do these two first because they require the least amount of work. So the formula would be sine of 30 times the cosine of 45 plus the sine of 45 times the cosine of 30. Using the hand trick, the sine of 30 is 1/2. The cosine of 30 is the square root of 3 over 2. And 45 is my match. So the square root of 2 over 2, square root of 2 over 2. When I multiply, I get the square root of the square root of 2 over 4 plus the square root of 6 over 4. You can leave it like this, or you can write it as square root of 2 plus square root of 6 over 4. Okay? Double check your work. And moving on to cosine. I need to clear some space. So cosine is cosine of 30 times the sine of 30 minus the sine of 30, the sine of 45. Well, I already did those in the previous problem. The cosine of 30 is the square root of 3 over 2 times the sine of 30, which is 1/2, minus the square root of 2 over 2. Oh, wait, I messed up. This should have been the cosine of 45. Sorry, I wrote the formula too fast. So that should be the square root of 2 over 2. And then this is the square root of 3. No, completely wrong. Sorry. 30 using the hand trick is 1 over 2, and 45 is the square root of 2 over 2. So it gives me the square root of 6 over 4 minus the square root of 2 over 4, which simplifies to the square root of 6 minus the square root of 2 over 4. Sorry, I made a mistake up here. Remember, it's cosine times cosine. All right, now tangent. Tangent is 1 plus tangent squared, and then 1 minus tangent of the first times tangent of the second. So that is going to be 1 plus tangent. Oh, I wrote the formula wrong. Hold 1 second. Okay, I mixed two of my formulas together. I'm sorry. This should be tan of A plus tan of B. All right, so tangent of 30 is, the tangent of 30 is 1 over the square root of 3 plus the tangent of 45, which is 1 over 1 minus the tangent of 30 times the tangent of 45, which gives me 1 over the square root of 3 plus 1 over 1 minus 1 over the square root of 3. Okay. So common denominator. If I rationalize this, it's the square root of 3 over 3 plus 3 over 3 over 1 minus the square root of 3 over 3. Okay, so now I need to multiply this by the opposite. So 1 plus the square root of 3 over 3. 1 plus the square root of 3 over 3. So let's leave this one as a 1 to make the work easier. So this becomes the square root of 3 over 3 because distribute the property, plus 3 over 3 plus 1, 3 over 9. Square root of 3 times square root of 3 is 3, and 3 times 3 is 9. And then we have to do 1 times the square root of 3 over 3. So that gives me, if I put this over 9 over 9, it gives me 2 the square root of 3 over 3 plus 12 over 9. 12 over 9 reduces to 4/3 over 1 minus 3 over 9, which becomes 6 over 9, which is 2/3. So then I'm going to multiply the top by 3/2. When I multiply the top by 3/2, because when you divide, you multiply by the reciprocal, we get, this cancels this, so it leaves me with 2, the square root of 3 over 2, then the 2's cancel, so just the square root of 3, and then these 3's cancel, and 4 divided by 2 is plus 2. So it ends up being the square root of 3 plus 2. Sorry, I did it kind of fast. Hopefully it wasn't too confusing.